I am Krishnamurthy Pammi. Welcome to the webinar on quality assurance through white box testing. First, let us understand what is white box testing. White box testing, as it means, it's basically by reviewing the code. It can be either in the static form of the code or the structural form of the code. Basically, we will go through the procedural aspects, structural aspects, and we will see the code and make sure that the code is written for the intended functionality. So here we will review the code and its structure and design. So that is the beauty of white box testing. In white box testing, you have two aspects. One is static testing, another is structural testing. Static testing can be done through test checking, code walkthrough, code inspection. These terms seems to be very familiar with you. I understand. So in this webinar, you will be refreshing your concepts there. At the same time, we will reflect on how these concepts can be used to improve quality assurance right from the beginning. When it comes to structural testing, we will see the binary aspects of the code. So let us see these things in detail. Static testing. First part of static testing is desk checking. It's basically done by the author itself. It is usually informal and person dependent. So if the author is very experienced, he can quickly go through the code and find out the errors. But if the author is not efficient, okay, and there is a possibility that he may miss some of the errors. So if in case errors are identified in desk checking by the author, the errors are detected and corrected with minimum delay. Fastest way he will correct the bugs. In this desk checking, the drawback is the author, in the hurry to complete his target program, he may not able to test all aspects or see all aspects of the code, meaning he may miss some of the scenarios in this process because he is an author and he may be biased about his own code. So there is a possibility that he may miss some of the expected functionality. Let's quickly glance through what is code walkthrough. It consists of group of people who actually review. So the programmer, he provides the code to the group of reviewers, okay, and those people go through the program and they ask questions to the developer or the author. So the developer answers. So the questions and answers will unfold like that. It all depends upon the capability of the reviewers to ask questions. For example, if they are experienced and if they know the specific aspects where the code can fail, in those areas, if they can ask questions, they can ignite the brains of the author. So it unearths or unfolds more number of defects. So if the reviewers choose to ask select part of the code only, means they ask questions only on the select part of the code, then only bugs or issues related to that part of the code only will get unearthed. So it all depends upon the reviewers, and if the reviewers focuses on entire code, which is not the likely case, in most scenarios they will be focusing specific to some aspects of the code. They will not go through in general 100% of the code. So here code walkthrough is another method where you open the program, you go through it, and reviewers ask the questions. But the positive aspects of it is it basically ignites the minds of the developer. For example, here reviewers will be, for example, 4 reviewers are there. So 4 reviewers, they'll apply their mind on in addition to the author. So 5 minds will be going through the program, and they will be seeing the program in a comprehensive way. Okay, so that actually will unearth lot of bugs at the early stage, and it can help fix the bugs well in advance. There is another code testing, that is code inspection. So code inspection or Fagan inspection, it is very highly structured and formal method. In code review, it is not that formal, but in code inspection or Fagan inspection, it is highly formal. Here, there are four distinct roles. One, the author of the code. Two, the moderator, who is expected to formally run the reviewers line by line. And third one is the inspectors or the code reviewers. And the fourth person is the scribe, who actually go minutes or the observations discussed in the meeting. So the code inspection, it is expected to cover 100% of the code, for the reason that the moderator makes the reviewer go through statement by statement, because the moderators facilitates to go through the code step by step. There is an opportunity that the reviewers will go through the entire code. So this way, there's a high possibility that entire code is inspected, and the observations are formally logged, and the observations are formally closed. So how it helps is, it helps in terms of detecting the bugs well early in the game. But now the question is, it takes a lot of time. Certain times you may feel that the amount of time you spend for code inspection versus the value you get, it may not balance given the business priorities in consideration. But however, it helps in terms of going through the entire code in its open form, and go through the code line by line, from communication from one function to another function, how it is happening, interface, how it's happening, whether variables are defined or not, how we can help improve the memory utilization. All those aspects also we can cover in these methods. So it all depends upon the efficiency of the inspector and the capability of the author to handle the feedback given by the reviewer. So generally, we see a scenario on the ground whenever we provide any review feedback. There's a possibility that others will take too personal and they try to negate it. So in that process, discussions may get deviated. So, but assuming that the reviewers and the moderator and the author and the scribe, they perform their roles efficiently, it is possible that this testing can unfold a lot of issues early in the game. Now let us talk. So far we have talked about three techniques under static testing. Remember, in static testing, we open the code, we go through it in a static form. That is why it is called static testing. Now the next question is how it is going to improve quality assurance. Because we are humans, right? Our brain is much more powerful than the computer. Our brain is a supercomputer which has given birth to a computer. So that's why we can detect more intelligent areas. For example, in the part of the program that we have reviewed, is there any unreachable code? As you remember, the more number of switch cases, if else statements and go to statements we use, there's a high possibility that while program is being executed in a dynamic form, the bugs the cursor may switch, or it may slip through some of the code, thereby some amount of the code may not be tested. So tomorrow it will become a baggage for us. So if we can able to identify the unreachable code through the efficiency of the reviewers as well as the efficiency of the author, this part of the issue can be prevented. Similarly, we will define lot of variables, we'll declare variables, but we may not be using it in the part of the program. So it may look very silly that if you go to highly stabilized companies, you see the functions, each function is written more than 200, 300 lines also. Okay, so there is high possibility that some of the variables are declared but not used, or the same variable is utilized in a wrong sequence. For example, an int variable is been assigned a float number in certain scenario. Because that certain scenario is not normally come across, your program won't fail. So when you go through in a, yeah, along with the group of reviewers, okay, this kind of issues can be prevented. Then third one, as I just now said, the right assignment of variables. The next one, which is most important, is allocated memory. Is it freed up or not when not necessary? So when these are the four intelligent things, okay, a manual brain or a human person can add value. When these things are tested and unearthed well before, definitely you are predicting the bugs well before in the game. Means at the beginning of the stage, you are basically preventing it. Okay, so friends, with this, I wanted to let you know this is how the static testing, where you actually go through the code, it basically improves quality assurance. Okay, let us now move on to structural testing. As I said before, in a static testing, we will see the code in open form, and we'll open the code and go through it function by function, statement by statement. But in structural testing, we actually use the product binaries against the pre-designed test cases. How? Let's go through it. First thing is code unit testing. You are all familiar with this. Developers use their integrated development environment tools to test through each step, to view their code. Basically, as part of unit testing, okay, developers tend to test the quick tests. What does it mean? It means for the set of code, they test the happy path, because they will be in a hurry to get their program executed, to code executed. So they perform quick tests. That's why we use the term quick tests. Okay, so but how code unit testing can help quality assurance? We have to think differently. There is a concept called test-driven development. See, if you take high-level analysis and we transform into technical requirements, also we call them as low-level design. So in the low-level design, you have requirement by requirement. Now, whenever you conduct a unit test case, okay, you have to first understand you are writing only the code that is required. Generally, there is a possibility that developers think and presume something and write more code there, which may not be tested in the future. So only the code required we have to write. So if you implement the concept of test-driven development, okay, in test-driven development, you first take the requirement, make sure that your code fails, because you just taken a requirement and you have not added any code there. Because you have not added any code there for that requirement, when you execute with that input, it fails. Now, to pass that particular test, okay, you make sure you add necessary code there. So now you have added the code there. What happens is, if you run the test will pass. Now you take next test case or next requirement. Then you execute it. When you execute it, because you have not added code for the test case 2, the code fails. Now after the code failed for the test case 2, because the fact that you have not added any question, what happens is you will now add code for the test case 2, and the test will now the program will pass because you've added the necessary code. Now you have two aspects. Aspect number 1, code required for the first requirement, code required for the second requirement. Now what happens is, by combining these two codes, there is a possibility of optimizing it. Maybe there are two variables you have defined, maybe you can combine, or maybe there's a common functionality between the code required to pass these two test cases, maybe you can optimize it. So there's an optimization. This cycle repeats. So this way it is a fun. The unit testing is a fun, and you add only the necessary test cases required. Okay, now let me go to the next aspect. The next aspect is code coverage testing. So friends, the code coverage can be done in terms of statement coverage, path coverage, condition coverage, functional coverage. So it's a simple mathematical form. Statement coverage is total statement exercised by the design tests into 100 by total number of executable statements in the program. Similarly, path coverage also, we have formulas here. Total paths exercised by design tests into 100 by total number of paths in the program. Similarly, conditions means number of Boolean conditions exercised by the design test into 100 by total number of decisions in the program. Functional coverage, total functions exercised by the design test into 100 by total number of functions in the program. Now, let's take some case here. Okay, this is the fun function I have taken. If you see this function, it is taking integer value as one of the input to the function. The moment you come to the inside the function, we are setting the variable total to 0, and then if the code is equal to m, there is statement 1, else statement 2. Of course, that needs to be corrected here. It's statement 2 here, and then percentage is value by total into 100, statement 2, statement 3, and if any error happens, then cache the error. Now, if the code is not equal to m, what happens? The cursor or the cursor slips to %. Then because the total value you have set to 0, then it fails. It doesn't even go through this. So it gets onto the error catch. So what I'm trying to convey is statement coverage testing is not that simple as it looks to be. It is not a sequential steps. You need to think in multiple angles, especially when you use if statement, when you use switch statement, when you use while statement, when you use for loops. Whenever you are using these kind of a thing, then you have to think in multiple angles and make sure that you write test cases in such a way that all the statements are executed. So statement testing is not a sequential testing, because whenever we use these in this objective, like if else, next is for loop, and then while loop, switch cases, then you have to think in multiple angles and write various test cases to address those scenarios. Okay, and then let's talk about path testing. See, I have taken a program here. Okay, the program looks like this. Okay, if month, the variable m is less than 1 or month is greater than 12, if it is true, means if month is less than 1 and month is greater than 12, then it's a true. Means if it's true, that means it's invalid date. If false, then I get into another program logic here. Assume that I give a test case with m equal to 0. If m equal to 0 I have given, that is month equal to 0 I give, it gets on to invalid date here. Okay, so that means it is not testing month is greater than 12, because even I am covering this path with just one condition, that is month is equal to 0. What happens if month is equal to 13? I have not tested, because in decision loop either or it becomes true. So path testing can help you gain more confidence compared to statement testing. But path testing alone will not give you the required confidence. You have to cover each Boolean condition. For example, you have to split the program in such a way that if m equal to 1, true or false, and then you have to test m equal to greater than 12. So, or either you modify the program, or you make sure that each condition you have to have test cases to satisfy each of the Boolean conditions. That's why if you see at the back, okay, the first is statement coverage, second one is path coverage, third one is condition coverage. In the condition coverage, we are covering all the Boolean conditions, and the fourth one is functional coverage. Generally, in object programming methods, okay, for each of the technical requirement or a logical set of technical requirement, you will be writing functions. So each function coverage will provide you confidence that you are covering all the specified requirements. So for example, if there are 100 functions out there, and if you are writing test cases to cover only 60, that means only 60% cases. So if you see statement coverage, path coverage, condition coverage, which is Boolean coverage, okay, or Boolean or for loop or whatever conditions, decision conditions, or function coverage, these basically advances one on top of each other. Now let me ask a question. Given your experience on the ground, when testers are executing the code, how many of us are actually focusing on code coverage? Believe me, my dear friends, with my experience on the ground, whenever testers or QA quality assurance professionals, they say, I'm done with the testing. When I say, what is code coverage testing? Answer is no. It's not, I don't want to blame them. It's because they are pressurized to perform certain set of test cases and make sure that that sanity testing or that limited number of functional test cases are working. But we have to think about code coverage testing. Then only quality assurance can be improved. How it improves? So code coverage testing, other than functional coverage, how it helps quality assurance? It helps performance analysis. My dear friends, when we use code coverage testing tools, okay, the testing tools, basically it organizes the program into different set of libraries called instrumentation. So the tool basically goes through the code and it segregates the program into libraries, and then it basically makes sure that which library or which section of the code or sector of the code is most touched, okay, and most touched. If specific part of the code is most touched, and now the point is, now if that is becoming a bottleneck, can I rewrite that specific piece of the code? Can I do it in a different way? Can I transfer the logic to middle layer or database layer to improve the performance? So basically, when you know what set of code sectors or libraries are most touched, okay, how to improve the performance, will get a lot of clues. Generally in the field, what we will get is customers will reply back to saying that I am taking, this program is taking more time, my users are providing some bad feedback, can you please work on it? And then we do in a reverse way. But in white box testing, right at the beginning itself, you can have a say of how to improve performance. The second one is resource analysis. For example, specific aspect of the code sectors or specific code files or specific program binaries, if they are taking more time, is it because my RAM is low, or by increasing my RAM, can I improve the performance? Whether all my hardware is properly utilized? Am I doing vertical and horizontal scaling properly? So that kind of resource usage analysis also, by looking at the in code coverage testing, we can derive. The next one is memory leaks. For example, the memory leaks is, for example, you define the variable and you forget to, you assign it and you forget to free the memory once you do not need it. But what happens is, slowly the memory bus shrinks and you will start getting performance problems. So those aspects also, by analyzing the code coverage and taking the help of the code coverage analysis from the tools, you can actually predict it. So my dear friends, how it improves code quality or quality assurance? Code coverage testing helps us a lot. So before I move on to cyclomatic complexity metric, let me see any questions are there. Okay, there is one question. Almost in all projects, I notice that always we prefer to write the code and run the test case. Okay, many of my colleagues argue with me why I need to run the test case to fail, because we already know we have not implemented. How do we convince them the benefit of test-driven development? Very good question, Jackie Sesha. See, look friends, I want to first ask, the developers should have the mindset of the testers. The testers should have the mindset of developers. Okay, now The moment you execute, see, for example, let me take two applications here. Application number one is WhatsApp application. Okay. In WhatsApp, I can guarantee that 60 to 70% of the features that you see, most of us use. Whereas if you take Microsoft Excel, probably 5 to 6% of the functionality that is available for us, or the features available for us, we are only using. You see, it's a great innovation. Microsoft Excel is a great innovation. Just by learning it itself, we will basically master the analytics aspect and be relevant to the business. But nobody is using it. So there is no need to write code that you think is relevant. You have to think the code or the program from the end user perspective. So when you have a test case now, you wanted to write only the code required that makes your code pass the test cases. So thereby you are not writing unnecessary test cases. You are not writing, you're not creating baggage for you. So Jackie Sesha, what I'm saying is, still, if your team is not able to believe in the benefits, there are two ways. A is take a pilot project, implement it, convince them, or otherwise take a good moderator or coach and take help of that person. Next, Pani. Pani is asking, my developers deny developers more unit tests, saying it requires a hell lot of work for covering complex code. Needs to do mock server response, DP network. Pani, I want to tell you upfront, attitude is our altitude. Okay, skill problem will fix it. Will problem we cannot fix it. So I think that this is fundamental aspects. So the reason why I have taken this webinar is, today we are talking about great testing concepts, but white box testing, black box testing, positive testing, boundary case testing, negative case testing, these are all born when the concept of testing got born. Are we doing it? Are we leveraging it? That's the question. So similarly, a unit testing we have to do. Now, yes, that's a very good question. There is Pani asked a question, what is the good percentage of code coverage? Devs spend a lot of time and ROI is questionable considering QA covers in system testing. For UI code, it is difficult to cover unit testing as well. Pani, wonderful question. Around 50 to 60% of the code coverage, if you get it, you are done a great job. More than 60% if you want to do, you have to spend an enormous effort. It all depends upon the ROI. Generally, the research says around 60 to 70% or around 50 to 70 in between. If you can able to achieve the code coverage, that's a great percentage. If you wanted to achieve 90%, I think you are spending a lot of time there. But if you use the concept like test-driven development, then you will insert code, only the code required to pass the test. Thereby, there is a high possibility of increasing the code coverage. Let us start our understanding on cyclomatic complexity metric. So what is cyclomatic complexity? Cyclomatic complexity measures the complexity of the program. Okay, it comes up with a metric and it basically quantifies the complexity of the program. How? We will see. And it measures the number of independent paths in the source code. And it mandates us to convert the program into a control flow diagram. Okay, let us take an example and understand how we can achieve it. Cyclomatic complexity method 1. We can calculate cyclomatic complexity under 3 ways. Okay, and it all depends upon the context you are in. Let us go through all the 3 methods here. So here, for a graph means the moment you see a program, you convert into a flow graph, okay, or control graph. So we say VG, the complexity, the cyclomatic complexity is represented here by VG. It is represented as edges, number of edges in the program minus number of nodes plus 2. Don't get puzzled. We will go through each of things and we'll make sure that you understand all these things. If you go to method 2, the second method of calculating cyclomatic complexity is number of predicate nodes plus 1. So what is predicate node? We will go through shortly. And third one is by number of regions. For example, cyclomatic complexity of a control flow diagram is just the number of regions involved there. How to calculate, how to view, we are going to discuss it very shortly. Let us take an example here. Okay, if one condition is satisfied, you are entering into another if statement. If condition 2, then you execute statement 1, else you execute statement 2, and then you get on to the if else loop is done, statement 3, and then now your main if statement else is here. So otherwise statement 4 and then statement 5. So this is what is the program. Okay, now we have to convert this program into a control flow diagram. How? You see here. Now first condition, if a condition 1, so that is my first node. Node is the intermediate aspects. Okay, edges are the lines, nodes are the checkboxes, the decision loops, or statements, all those things. So here it is, if you see, this is converted into n1 is a condition. If it is true, you are entering into next if statement. That's what is written here. If condition 2. If it is true, you are coming into statement 1. If it is false, you are coming into statement 2. And then in either of these scenarios, you are coming into n5, that is which is statement 3. And then your else part means this if conditions else part is here, which is statement 4. So you are coming in this way, and statement number 4, and ultimately statement number 5. Okay, so n7. So this is what we have done using this step is we have basically calculated, we have just converted the program into a control flow diagram. Now I will explain how to calculate nodes. Okay, see here, as I said, nodes is nothing but the nodes. For example, n1 node is the joins. Okay, so the executable statements, that can be a decision conditions or a statements. Okay, n1 is a condition 1, n2 is another condition, n3, n4, n5, n6, and n7. So what is happening? There are 7 nodes here. So how many nodes? Nodes are nothing but the collection of executable statements. That can be a simple statement or conditional statements. Okay, now so there are 7 nodes in our example. Let me go to the next example. What are predicate nodes? Predicate nodes are the nodes which are conditional, meaning it should bifurcate into either or, this way or that way, true or false. So those are the predicate nodes. So in the earlier slide we have seen number of nodes are 7, but in our case the number of predicate nodes where the decisions this way or that way, true or false is happening is only 2, P1 and P2. So if you see in our program also, there are if statement, 2 if statements there. That's why you say there are 2 predicate nodes are there. So for what we have learned what is node. Node is the collection of executable statements. Predicate node is number of conditional statements. That can be, the condition can be either this way or that way. Okay, that is the next point. So third one is the edges. Edges are nothing but your lines that connects the nodes. For example, if you see here 1, 2, 3, 4, okay, 5, 6, 7, and here it is 8. Total 8 nodes are there. 8 edges are there. So far what we have learned, nodes, which is nothing but your joints, predicate nodes, which are nothing but your conditional statements. That can be a if statement or any conditions in for, while, all those things, this way or that way. It should basically branch out to only 2. That's the key. Okay, the key here is if your if statement or switch statement is actually branching out to 3, you have to modify your program in such a way that you have the conditional statements that will branch into 2 statements. For example, let me say here, let me go to predicate nodes. Here if you see P1 and P2, P1 is true or false, it's separating. P2 also this condition true or false coming. Whereas N5 is a statement, it is not a predicate node because it is not branching out. It is the N3 and N4 are culminating or joining at N5. But N5 is not getting separated into two statements. That's why N5 is not a predicate node. Only P1 and P2 are the predicate nodes. Okay, now we have also understood what are edges. Edges are nothing but the lines connecting the nodes. Okay, so we have 8 edges here. And then how to calculate cyclomatic complexity metric using method 1. So number of edges minus number of nodes plus 2. We have seen earlier in the slide that 8 are number of edges in our example, 7 are nodes, and plus 2. For a single program or subroutine for a graph, this is the formula. This cyclomatic complexity is number of edges minus number of nodes plus 2 applies. Okay, so the cyclomatic complexity by this method is 3. Let me go through the next method. Okay, this method says identify how many are your predicate nodes. You just add 1 to that. So in our condition, there are 2 predicate nodes are there, 2 conditional statements are there. So 2 plus 1 is equal to 3. So if you go by earlier method, still you are getting 3. By method 2 also you are getting 3. Let us go to third method, which is region method. Region method is nothing but how many regions or subloops you can actually divide your flow diagram. So if you see here, this is the region 1 is the flow here. Okay, this is the first region because this is the first subloop. Okay, let's go to second one. Second one is other than region 1, there is region 2 because this is another subloop. Okay, so earlier we said this is region 1. Now this is another region because this is another subloop. And the third one is the whole universe on which your flow diagram is happening. So that is why generally people say if you want to identify number of regions, number of subloops plus 1, they say. The plus 1 is actually relating to the holistic one. So region 3 is the whole region on which your flow diagram is coming. So this way you have 3 regions. Region 1 pertaining to this particular subloop, region 2 pertaining to this particular subloop, and region 3 is entire thing. So number of regions is 3. So if you see the third one, it says that if you want to identify cyclomatic complexity, it just based upon number of regions. So regions is 3. So whether you go with edges and nodes method or predicate node method or region method, you basically arriving at the same number. But in some scenarios, you may not use some of the methods here. For example, in some situations, you may not able to identify predicate nodes. So in that way, you may go with E minus N plus 2, that formula. But in our case, we could able to apply all the 3 scenarios. Fine. You can ask a question. Okay, fine. What does it mean? What is the cyclomatic complexity mean to me? It means the number of independent paths for you. Independent paths, meaning, for example, if you take this particular case, okay, N1, N2, N4, I'll say N1, N2, N4, N5, N6, and N7 is one path. The other path, what is independent path? It is a path where at least one edge has not been traversed before. For example, in this path, N1, N2, N4, N5, N6, N7, N3 has not been executed. So in the second path, N1, N2, N1, N2, N3, N5, N6, and N7. The third path is N1, N6, and N7. So these are the 3 independent basic paths we have in our program. Now, the question is, if we have 3 independent paths, what does it mean? Meaning you have to have the 3 test cases to execute this particular program. Now that it is a simple program, we are able to identify 3 paths. But in case of a complex program having more number of functions, then more number of lines of code, then tools will generate these graphs for you, and also the cyclomatic complexity they will calculate and give it for you. In that situation, you say, okay, if my cyclomatic complexity is 8, then I must have 8 test cases to make sure that I cover all the conditions, and give me a good coverage. More than the number of coverage or number, it all how early in the game I'm able to identify the bugs. Okay, so how does this metric helps me? It helps that, if the cyclomatic complexity falls between 1 and 10, it means the code is well written, the high testability of the code, and cost to maintain is low. So it is giving three aspects: whether the code is written properly, testability, and cost to maintain or effort to maintain also it gives you. So 10 to 20, moderately complex code, testability is medium, and cost or effort to maintain is medium. 20 to 40, very complex code, testability is low, cost or effort is huge. Greater than 40 means not at all testable, cost or effort to maintain is huge. So basically, by looking at the cyclomatic complexity metric at the time of testing, we are understanding whether the program is properly written or not, testability is high or not, cost or effort required to maintain that program or function is more or less. So we generally suggest between 3 to 8 is the number that we generally ask the developers or to come to. Okay, so it also tells you, as I just said, it also tells you the number of independent paths. So it gives us the upper bound on the number of test cases to be written. So what happens practically? Practically happens is, we just take some code, cut and paste it, because whenever a new requirement is given to a developer, in most scenarios, and at least 60% scenarios I see, and I have with due regards to developer community, but more or less they wanted to copy the code, similar code, put it, and then change the required variables and change the required code and execute it. So their intention is, by doing this, they basically achieve better predictability. But if the program, that the source that they have copied from, if that is not properly written, then you are actually adding more baggage. And so cyclomatic complexity metrics gives these indicators about how well you have written a program, testability is high or not, cost required to maintain it, very early in the stage of software development. So friends, how does the white box testing helps us? Why it improves quality assurance? Friends, it is important to talk about what is quality assurance. Quality assurance gives confidence to the organization uh, to make sure that the bugs are prevented or nullified from reaching the end customer. That means till you complete your delivery, you wanted to prevent or you wanted to minimize all possible bugs. You wanted to have such practices. For example, whenever you talk about code review, the code review is nothing but to capture bugs as early as possible. So quality assurance practices, they give you confidence. Okay, now using white box testing, okay, what are you doing? It's basically you are improving sound knowledge of the program code. Today, most of the developers and testers, they are going into different branches. Agile is coming and saying both are same. Tester also, we call them as developer. But the mindset has to change. The point is, tester is a good profession. It's an important profession. They have end user perspective in mind, and that perspective developers should have. Similarly, testers also, if they get insights about the procedural logic implemented in the code, okay, they will think in a more better way. So basically, hand in hand, developers and testers work together throughout the process. So instead of identifying bugs at the end and logging, you are getting those bugs during development stage itself. So basically, from testers, you are getting end user scenarios, end user knowledge. Because my dear friends, if end user knowledge is not there, okay, even though your code coverage is proper, all static testing, structural testing, all those things are proper, what happens is you are writing code for a wrong requirement. So one should have the end user perspective of the requirements. From that only you have to write the code. Generally, if the developers and testers lack the end user perspective, what happens is you are writing the code with all good statistics, code coverage, static testing, all those things for wrong requirements. Nobody can help us. So that's why white box testing, if you can basically, if business analysts also, if he also participate in key discussions, what happens is the end user perspective, people understand it, there'll be more conversations happening, and then there will be knowledge transfer also happens, and then tomorrow even if people, we will step up more number of skilled people on job, on training. For example, today, even though we call people and we arrange training for them, it is generic training, but we need on job our need basis training. So white box testing, where you actually open up your own code and you go through it and you understand the logic. At the end of the day, whether you talk about C, Java, .NET, whatever it is, it's basically a business flow. Even the system words also, they are written such a way that at least 60% of those languages anybody can understand. You don't need to actually gain insights of assembly language and all to understand them. At least at the UI level or the middle layer level, the functions are written in such a way, the variables are written, declared in such a way, saying that a business analyst can understand. So in this way, it improves the knowledge of the program. It makes sure developers and testers work hand in hand, and you are actually predicting or discovering more number of bugs early in the game, and you are going to eradicate or minimize those bugs. So this way, you are minimizing the bugs. You are zeroing the bugs from reaching the end customer. That's why, my dear friends, quality assurance will be improved if you implement white box testing. My few cents towards the end is like this. Today we are talking about test driven development, behavior driven development, acceptance driven development. All those things are fine. We may welcome those things, but we should not forget the fundamentals of testing. Today, white box testing, where or black box testing, those things are the things where basically the testing concepts got born. So we should basically make sure that we revisit our concepts time to time, and make sure that we add that value to the business program we are in. So that's all about white box testing. Let me see the questions. Okay, how do you apply these in agile development methodology? See, Pani, first question is, in agile, teams are empowered. Okay, now there is a definition of done is there. What is the definition of done? It all depends upon the team and context, but in agile environment, team sits together and set the definition of done. My code unit testing is signed off. What does it means, unit testing? How many unit test cases you are executing? What is the relevance of code unit testing with respect to the technical requirements you are going to address? Where is that? Where is the logic? So teams are empowered. So what I'm saying is, white box testing concepts, they can apply. Nobody is going to stop them. So within that sprint duration, teams are empowered to make sure that they produce quality software. So white box testing, black box testing, any traditional concepts, they can apply. Okay, today I want to ask a question. How many of us know as a managers, or leads, when somebody says testing sign off, then what is the coverage? Nobody, no clue. At least 90% scenarios we don't see. But if there exists an opportunity where a tester signs off saying that this is my code coverage, this is my statement coverage, this is my path coverage, I mean, that's the great scenario to be in. So to answer your question, agile is empowering team. So we can certainly use these concepts. It's up to the team. Okay, let me say next question. How to find memory leaks using structural testing? Okay, see, the point is like this. As I said, the code is being instrumented into different libraries or sectors. Okay, now from sector to sector, the processing time is gradually decreasing. What does it mean? See, for example, from sector to sector, there's a pattern of execution time increase. What does this mean? it basically helps you know, okay, is it that I have to free up some memory? Am I using it, or where from the calls are coming? Similarly, I just wanted to ask, I just tell another scenario: security testing. For example, today, and to address the virus problems, security problems, today, this white box testing helps us. Okay, this is the procedure. This procedure is called from what all programs and how it responds. So that aspect, if you actually analyze, it provides hints about how to prevent the security leaks also. So to answer your question on memory leaks, the pattern of execution time, first it helps you to identify, am I freeing up the memories or not? If you free up all the memory, still the execution time is not proper, then you probably need to add hardware for in terms of vertical scaling or horizontal scaling. Let me take another question. Uh, okay, there is question from Khaja. To test code quality, developers write unit test real JUnits code flow. With respect to verifying test cases, integrated tests, correct operations are added. I hope it would be better to make this distinction between unit tests versus integration tests. Thanks, Khaja. That's a good observation. Okay, and what percentage of allocation time to be allocated for unit testing? Oh, I mean, we can't say like this. See, at the end of the day, Pani, it is a passion. Okay, there are some people. Okay, uh, if you look at the program, you'll be really thrilled to see the program. For example, there will be proper indentation, proper comments, how the flow is going. All those things they write not because somebody appreciates. They write because they like it. So that's why I say, it's not about the number of years of experience based on which we will be judged. It's about the quality of work, how we approach towards our task, that matters. So that's why if you see, it's not, I can't say it's about how much percentage. It all depends upon your positioning. We can't come up with statistics there. It depends upon context and the organization. Let me take another question from Jackie Sesha. Almost all in projects, I notice that always we prefer to write the code and run the test case. Okay. Many of my colleagues argue with me why I need to run test case or fail. I think we have already taken this. We have taken this question. Yeah. What percent of allocation will get testing? I think we have taken. How to find memory leak? How do okay, well, okay. Next question. How this can be applied in data science projects? See, in data science projects, okay, in data science, you will be doing data mining, you'll be doing data analytics, you'll be doing, I mean, today data is more prominent. Today in newspaper, I'm reading that Facebook data is being analyzed and utilized for different purposes by third-party agents. That's what I read in the newspaper today. So data today is becoming a very powerful source of predicting the user patterns. So white box testing, for example, whatever procedures you build on top of the data, okay, that can be a stored procedure, or that can be a functions or analytic aspects or reports. Okay, at the end of the day, it is a requirement only, right? So this requirement, I wanted to make sure that for all the requirements I do a proper code coverage. I go through the static testing aspect, I go through it in open form and help address it. So basically this is a common mindset. It's a mindset. White box testing and black box testing, all these things are mindsets. It expects us to understand end user requirement. So to answer your question on data sciences, we have end user requirements. As long as end user requirement is there, definitely end user need not be a customer. Okay, the person who is consuming your services also is your user. Okay, maybe a API user, application programming interface user, maybe your consumer or user. So his requirement is what drives you to drive the development. Okay, let me take another question. Sorry. Project and how do you apply this agile development? Yeah, I think we have covered. Okay, Divakar is asking a question. Nice capsule of, okay, thanks Divakar. Thanks, Divakar. Next question is how to write unit test cases. Oh yeah, so it's basically how to write unit test cases is something, I can tell you quickly. It's better always you have to write a test case like this. What are you expecting? Under what trigger should happen, and then under what scenario. That's why in Agile we come up with a structure saying that given a situation, when a trigger happens, then the expected condition. So when you write in this particular 3-term package, given the situation, when a trigger happens, then I expect the expected criteria. So these 3 things will give you what was the context, what was the trigger, and what is the expected outcome. See, for example, I'm telling you, as a father of a child, you may not be happy with your school. Okay, just because you are in a situation that you are not happy with your school, you will not change. Some trigger should happen. Okay, the trigger can be a wrong feedback on your child from your teacher. When you go and talk to the student, to the teacher, you find that the teacher is not so not fair on your child. So what happens is that is a trigger for you to change the school. So what I'm saying is, even though a specific situation happens, that may not be sufficient for you to take a decision. A trigger should happen. So when given a situation, when a trigger happens, then the expected criteria. If you write the test like this, it will help a lot. Friends, I think we came to the end of the webinar. If you have still questions, you can write to me. Thanks a lot. Thank you for your time. Thank you.